Okay, the first thing I want you guys doing today, we're talking about transformations as functions. This next unit is all about transformations, so we're going to dig into this quite a bit, but I wanted to start off today reminding you guys of what functions are and kind of seeing how transformations in geometry are our functions. Okay, so being aware of that, can anyone remember what a function is? X and a Y. Okay, you're circling around the right idea. So one of the main ideas, you said X and Y, but really we think of it as input and output. Okay? If you can't think of what the central idea of a function is right now, we're going to come back to that later. So let's just kind of push pause on that. And what you do know is, hopefully, you remember how to input values into a function to evaluate it. So you've got three problems at the top here. What is the value of function f of x at or when x equals a number? So go ahead, plug those numbers in, evaluate the functions at those inputs. All right, let's go ahead and look through this in a minute. All right. So what is the value of this function? Remember, and some of you needed some reminding, but some of you were getting it done pretty quickly. What we're saying is we want to plug in 4 for our x values. So it's going to be f of 4, and that's whenever we just plug that in. Anywhere there's an x, we plug 4 in. All right, so now what's 4 squared? Okay, and this is also a common mistake right here. You do your exponents first before you multiply. It's not 2 times 4, then square it. You square the 4, and then you multiply by 2. All right. 2 times 16, what do we get? 32. And that 32 plus 4 gives us a final answer of 36.
Still the same thing.
How's it?
It's like if you multiply it, like 2 times 4, an exponent. So
Well, 2 times 4, if you had done that first, you'd have gotten 8 squared, which is 64.
that's what I did.
Well, 64, okay, well, the order of operations has to be done correctly every single time, so the exponents have to happen first. And so if you plugged in your calculator, then your calculator was using the order of operations. Yeah. So, next one, we have f of 11, because they told us to use our x value of 11. So now we've got negative 5 times 11 plus 1. And what is negative 5 times 11? Negative 55. And add 1 to that, you get? There you go. All right, so you guys are remembering this. The last one is probably the most confusing for people, just because it has that fraction in it. So if I do f of 5 for the function negative 2 over 5 times x, so that's going to be times 5. Now you can do this by hand, you can do it on the calculator. If you do it by hand, then the easy way of doing that is remembering that a whole number is just the same as that number over 1. And I'll show you what I mean. I'm going to have negative 2/5 times, and this is going to be the same as 5 over 1. Okay? And the reason I would do that is now I can see I'm just multiplying two fractions together. And what that gives me is multiplying the numerators together. Negative 2 times 5 is what? Negative 10. And 5 times 1 is 5. So now my final answer, negative 10 divided by 5 is negative 2. All right, so f of 5 in this case, make sure you guys aren't talking right now, is negative 2. Okay, now you can do this on your calculator. I will introduce this again, so I guess reintroduce it later. But we have this function here on your calculator, it's a and then b over c in the top left. that will create a fraction for you. So you can hit your -2, hit that button, you'll get this backwards small l, and then 5, and what your calculator is reading that as is -2/5, and it'll give you answer in terms of fractions as well. So we'll come back to that, but if you want to already be aware that there is a fraction function, then there it is. All right, not super important for right now. Don't worry, I'll take care of it. Okay, let's look at the bottom part now. And we were talking about functions. Let me go back to the functions just real quick, because one thing that you should be aware of is right here, when we say f of x equals whatever the equation is, f is the name of our function. We could call this g of x, h of x. Kind of the standard notation for it is going to be f of x. All right? And that's important because we have our own kind of functions in geometry, and they can take on lots of different names too. And it's just important to understand when we're talking about just the name of the function and when the letters actually mean something. Okay, so if we come down here to the bottom, our geometric functions are what we call coordinate rules. Okay? So I will highlight this word coordinate rule, and it kind of gives you an explanation right there. So just like we have those terms input and output for a function, we have similar terms for a coordinate rule. We have our preimage and image. So you can use them interchangeably almost, but a lot of times I'm going to refer to them as the preimage and the image. Preimage is what you start with. After you've done the transformation, you're going to get an image as an output. Okay? And we've got some notation that we've already introduced, but I just want to remind you of it. If the preimage is point A, then its image is going to be A prime. And the prime notation tells us that it's an image. And this is really important. I'm going to give you guys an example real quick. If I had a diagram right here that had the letters A, B, and C, and then another one over here that had A prime, B prime, and then C prime, just looking at that, you should be able to determine which one is, where did it start from and where did it end at. So which is the preimage here? ABC or A prime, B prime, C prime? ABC. That's the preimage. A prime, B prime, C prime is the image. And I tell you this now because sometimes that's the only information you're given. And then the question might be, what is the transformation? Okay? So let's go back to this. And I added some highlighting. Make sure you're taking note of that as well. So the coordinate rule looks a little bit different. If we come back up here to where it says input, output, preimage, image, notice that you have this T right here. This is the name of your coordinate rule. And we're going to derive a bunch of these coordinate rules as we go through this unit. And we're going to give them specific names, just so we are always referring to them the same way. So T in this case, we got X and Y. This is your input. Because we're dealing with shapes on a coordinate plane, these are going to be coordinates as inputs, and we're going to get coordinates as output. One thing that's kind of hard to tell sometimes is that there's a comma right here. And sometimes people don't notice that. So there's always a comma separating our X output from our Y output. All right? And you can see what's happening. We're going to take our X input, plug it in, and add 3 to it. We're going to take our Y input, plug it in, and subtract 6 from it. All right? Now, we're not going to do that coordinate rule right now. We're going to use this one down at the bottom. So I'm going to run through this one with you guys. Given coordinate rule M of xy, the output is going to be 3x minus 1 for the x, and then 5y for the y coordinate. And this is one where it's, you can miss that comma pretty easily. So let's see what's going to happen. We're going to use an input of point A, which is 3, 2. So x value of 3, y value of 2. Now, the notation looks a little bit similar here between the coordinate rule and the point. But just keep in mind the coordinate rule is going to give you also kind of the definition of it. And this is just a point. All right? Hopefully that's clear enough. So this is what I'm going to do. M of, instead of xy, I'm going to do m of 3, comma 2. And the way I want to approach this is this x value right here is going to be my input wherever there's an x. And the y value right here is going to be my input wherever there's a y. There you go. Okay, so looking at this, instead of 3x minus 1, I'm going to have 3. Well, my x value is 3, so it's going to be 3 times 3 minus 1, comma. Now I'm going to go for my y value. Instead of 5 times y, I'm going to have 5 times 2. And I'm going to stop right there. Are there any questions on what we just did right here? Is it making sense how we're using both the x and y as inputs? Okay. So now it's pretty straightforward calculations. That was the hard part, making sure that you plug the correct numbers in the correct spot. But now we can just do, what is 3 times 3 minus 1?
8.
Yeah, it's 8. There you go. And 5 times 2 is? 10. All right, so when we plug in m of this coordinate 3, 2, then we get an output of 8, 10. All right, is that making sense? And that means on a coordinate plane, I'll give you guys a second to write that down if anyone's still trying to do anything. Okay, on a coordinate plane, let me come over here to this blank space again. If I started with 3, 2, let's say it's about right here. So this is my A, where I started at. Then A prime would be over 8, 10. I'd have to go further to the right, further up, and let's say it's about right here. So that's where I started from, and that's where I ended, up there in the top right. If we took a lot of points, we'd be able to see kind of what this looks like as a trend. Okay. So go ahead and try this next one. You already have the coordinate rule given. You have the input. So see if you can figure out what the output, what the image is going to be. Okay, I'm glad we're going over this. There's a lot of confusion on this just because of, different points of confusion. So make sure that in this case, you're doing W of -1, -2. That's your input. So they tell you this is point B that we're going to be evaluating this for. And now, remember, your X value gets substituted in for X. Your Y value gets substituted in for Y. And then you just evaluate. So, when I plug this in, I should have -1 minus 4. And then -3 times -2. So my inputs won't be the same every single time. And actually, most people were good with that part. But some people were plugging in the wrong values. Some people were plugging in the wrong spot and having some troubles that way. But now we can look at our x coordinate right here, which is just -1 minus 4. What is -1 minus 4? -5. And then -3 times -2 is?
6.
It's +6. Okay, you're going to get a coordinate as your output. You have that that comma there in the middle, and that separates your x from your y. So W of -1, -2 gives me an image of -5, 6. All right? And the other thing that caused some confusion, if you've got a number and then a -4 next to it, that's not showing multiplication, that's showing subtraction. This -3y, that -3 is out in front, that's the coefficient for the variable, and the implied operation is always multiplication. So that's why we multiplied those two together. Okay, so there we are. Now we're going to come back to coordinate rules. We're just kind of introducing them a bit today, but we're going to be using these an awful lot. I want to go back now, and on the top of the next page, you can see you're given a function, just a regular algebraic function, f of x equals x squared. And it gives you 4 input values, a, b, c, and d right here. You've got f of -2, f of 2, f of 0, and f of 5. See if you guys can go through and get the outputs for those 4 inputs. Okay, so I just remember, I'm just going to show you this for the first 2. What we're talking about is f of -2, which will be -2 squared, and then f of 2 will be 2 squared, and then so on. So what did you get for f of -2? Go ahead. Or are you offering? 4. There you go. Thanks, Nick. F of 2 is 4. So these are the same. Keep in mind, -2 times -2, the negatives cancel out, you get a positive. All right, if you do this in the calculator, you have to be very careful that you don't just write -2 and then hit your squared button, because what your calculator is going to read that as is -2 squared. So it's not going to see that that's -2. That's just one number. It's going to find the 2 squared and then turn it negative. All right, f of 0 is 0, and f of 5 is 25. So we're saying 5 squared is 25. All right, so now what we want to do, we're going to come over to these boxes. We got domain and range. Remember these terms. Domain is going to be your set of inputs. Range is your set of outputs. All right, and you can see your 4 inputs there in the domain. We're only going to write the unique values that show up in the range. So what values are we going to write? 4. 0, and 25. So in this domain, we've got 3 outputs. And with these puddle diagrams, this is the name we have for it, remember, we're going to draw arrows from the input to its output. All right. So I've got -2 and 2 both pointing to 4. I've got 0 pointing to 0, 5 pointing to 25. And now the question, I asked this before, but I didn't hear the exact answer. But let's come to it now. Is this a function?
Yes.
It is a function. There it is. Each input has only one output. So the way you can see this, the puddle diagram makes this really visual. Each input has only one arrow coming from it. So everything in the domain only has one arrow leading away from it. So yes, it is a function. Some people might not have thought this was a function, and that's because that you're kind of thinking of the next question. Is it a one-to-one function? All right, and you might not know what one-to-one means. But let's think about this. If a function is where every input has only one output, then a one-to-one function is one where also every output has only one input. So is this one-to-one? No. Now there's a few ways you can kind of think through this. First of all, you can just look and you can see that -2 and 2 both point to 4. So this output in our range 4 has 2 different inputs. So that automatically makes it where it can't be one-to-one. But the other way of thinking about this, how many inputs do we have? How many outputs do we have? We have 4 inputs, 3 outputs. If it's one-to-one, you're going to have the exact same number. of inputs as outputs. If you ever have more outputs than inputs, then it's not a function. Okay. So let's go ahead and do the next one. I'll just give you guys a little bit of time, run through, do the calculations for that one as well. And I'm not going to give you as much here. Hopefully you guys know how to input the values at this point. So take a minute or two to do that. All right, so when you did f of negative 2, what did you get? 16. F of 2 gave you what? Negative 4. You should have got negative 4. F of 0 gave you 6. And f of 5 should have given you negative 19. All right. So we can look at that last one because I know that this one's so far is the most people have gotten it wrong. So if you've got f of 5, it's f right there of 5, then that's going to be negative 5 times 5 plus 6. And negative 5 times 5 is negative 25 plus 6 will give you that 19. Negative 19, sorry. Not right now. Okay. So, let's look at the domain and range. Let's write down all of our outputs. We had 16, negative 4, 6, and negative 19. Draw your arrows from each input to their output. Okay, so we got our puddle diagram finished up. Lee, sit up. Okay, and what is is this a function?
Yes.
Yes, it is. Is it a one-to-one function?
Yes.
All right, so now we have a visual on what a one-to-one looks like. Each input only has one output. Each output has only one input. And the number of inputs equals the number of outputs. So it's kind of redundant ways of looking at it. Okay, so go through real quick and decide for yourself if these next ones, problem number 4, A, B, and C, determine if those are functions. And just about 30 seconds is all you'll need. All right, so it's just a really quick yes or no on if these are functions. The first one, is it a function?
No.
Does each input have only one output? Yes. It is a function. The second one, function yes or no? Yes, definitely. And the last one, function yes or no? No. Okay, so let's go through these one more time. And I'm going to ask, is this one-to-one? So for A, is that one-to-one? No. Is this one one-to-one?
Yes.
Yes. And then this one isn't even a function, so it's not going to be one-to-one. We don't have to worry about that. Now, as far as, now we can see a diagram like this, but as far as things that you're familiar with that can be considered not functions, just so you have kind of an awareness of this, if you don't restrict the range, then this is not a function. All right, now that looks like something kind of normal that you guys have seen before, square root of x. But this, if you don't restrict the range, then this would not be a function. And a lot of time it's considered one, but consider this. What is the square root? If I did f of 4, what is the square root of 4? Square root.
2.
It's going to be 2, but could it be positive or negative 2? All right, so this is why we can get two different answers for the same input. Now, a lot of times what people say is only give the positive square root. And then it's a function, because then there's only one answer. But if you don't restrict it that way, then it's not a function according to the definition. One thing you also learned was that vertical line test. It doesn't pass the vertical line test. Okay, so let's try and finish this out if we can. We're going to now look at this from a geometric point of view. We've got our input and output, and it says that the preimage is ABCD, The output is going to be whatever we have left over. So we're going to determine if each of these are mappings. Mapping is a term we use to say if it's a function. Okay? So we'll just run through this together. So we can map if we can connect each input point, and I'm drawing these arrows. I'm treating this kind of like a puddle diagram. If I can map each one of these points to another point on the other figure. So I've used up all my pre-image points, A, B, C, and D, and they all have an output. Is this a mapping? Yes. Yeah, and let me just rephrase. Is that a function? Which you already said yes. Okay, now the next one. I'm going to connect A over to E, B over to H, C over to E, and D over to H. Is this a mapping?
No.
Does each input have only one output? Yeah, each pre-image has only one image. Yeah.
Doesn't it have to be the same exact shape?
No, it doesn't. Even if it's, and we're going to talk about transformations, which is something more specific, even transformations don't have to end up the same shape. So we're going to talk about that. And then the last one, you can probably already see what's happening here, but let's just go through it. A connects to I. B connects over here to J. C connects to K. D connects to L. Well, we still have more output points. So A connects over to M. B connects over to N. And C connects over to O. Is this a mapping? No. There are 3 inputs that have 2 outputs. So no, this does not work. Okay. So now we get to the distinction between a mapping, and we don't really use this term after today. We don't talk about mappings. We're going to talk about transformations. Okay? So which of these do you think is a transformation? A, B, or C? A. And why is A a transformation? Why is it specifically called a transformation? Okay, there's a letter for each one. So think about it in terms of our functions. We had a special name for this type of function. What do we call it? One-to-one. So think about this. And just keep paying attention, guys. Each input has only one output here, but each output has only one input. So basically I start off with 4 vertices, I end with 4 vertices. So that makes it a one-to-one mapping. That makes it a transformation, okay? So this is what we're going to kind of end with today. Transformations are one-to-one functions on a plane. All right. So you guys will get more practice with coordinate rules, and we're going to derive our own. I already mentioned that. So just make sure that everything was making sense for today, and if you have questions, let me know before the bell rings.